Hi guys, in this video let's discuss something about numbers. So what are the questions that we can expect on numbers? So one of the most prominent question or a most possible question that we can get is to reverse a given number. How can we reverse a given number? So let's say we are given 1, 2, 3. So this is a number. So the output that is being expected is 3, 2, 1. Okay, if it was a string, then it's a very easy process. It's a very easy process because let's say this is a string. So if this is a string, then all these are just characters. So how can I reverse a string of characters? Okay, if these are characters, then we can assign two pointers I and j, and we are going to swap the values I and j. If we swap them, okay, let's take a bigger example. Let's take 1 2 3 4. We're going to keep the pointer I here and the pointer j, and we're going to swap these two values. So now we have 4 2 3 1. This is still not reversed, and still we have I pointer here and the j pointer is still here. Now we have to move I pointer to next, and so we have to increment the I pointer and we have to decrement the j pointer. So now the I is here, j is here. Okay, now I can swap both of them. Now we have 4 3 2 1. Now we have I here and j here. If we increment I and decrement j, then we'll have j here and I here. So we have to do this iteration only if I is less than or equal to j. So there is a condition where I and j may also point to the same location. So we shouldn't also consider that case as well, because if it is a single element, then we don't have, so then we don't need to swap it. So in this case, so we're gonna swap I and j, so we get 3 1. 3 1 will be swapped, and then I will be at 2 and also j. Then what's the point of swapping 2 with 2? It's useless, so we're not gonna do that. So we're gonna have a loop while I is less than j. We're gonna swap I and j. So we're gonna swap I and j, the value, and that's it. So we can reverse the string. So we can reverse the string. Okay, so this is a very efficient solution, but it's not always the case that they will be given as a string. But what if they are given as a number? How can we reverse an integer? So let us take another. So if it is a number, then I don't have I cannot access each of these elements by using indexing, because they are not characters, they are numbers, they hold a place value. So what can I do? So remember, so do you I hope you remember this operator called modulo, right? So what will happen when I do 123 mod 10? You should only specifically use 10 because we are trying to get the last digit. Okay, we have the last digit, right? So if I do this, I'm going to get the answer as 3. Okay, and also I would like to do another operation along with this. I'm going to do another operation. I'm going to divide 123 by 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 the value by the value 10, and I'm also going to assign this value to let's say this is n. I'm going to assign this value to n. So what will happen? The value of this expression is 12. So our new n value is now 12. It's not 123 anymore because I have updated it. Now let's do the same operation. Mod 10. Okay, now I got 2. Okay, it's another digit. Now I'm gonna do 12 by 10, and my answer would be 1.2, but we are not looking for a fraction, so it will be 1. The integer value will be 1. So now my new n value is 1. So let me do 1 mod 10. So 1 mod 10 is nothing but 1, right? Along with this operation, I'm going to do 1 divided by 10. So this would be 0.1, that is 0. So when I get 0, I mean there is no point doing 0 mod 10, it will always be 0. So I'm going to stop here. I'm going to stop when n value becomes 0. So this is the n value, right? I'm going to stop when n's value becomes 0. Okay, so doing this loop, what did I get? So I'm looping. So I'm saying while n is greater than 0, you get the last digit. So last digit is equals to the n mod with 10. So this is my last digit, and I am going to modify my n to be n divided by 10. So doing this LD in each iteration is going to contain the last digit. So how can I use that to reverse? Now, so this can be used for another program. Okay, if they ask you to uh, print the sum, uh, print the sum of individual digits, then you can say sum is 0, and here you can say sum plus equals to the last digit. So you're going to add all the last digits and get the sum. But this is not our problem. So we're trying to reverse that. So how can I reverse it? So can I see any pattern? So what's up with 3, what's up with 2, what's up with 1, and see how they are related here. So by seeing that, I can understand that. So 3 is the first digit, and that is actually my last digit. So do I have any relation with 3? Okay, I don't kind of remember anything, but I do get an idea that I'm actually dividing this with 10. So let me just multiply that with 10. How would that be? Okay, if I multiply that, if I multiply 3 with 10, I'm going to get 30. Okay, let me add 30 into 2. Will it work? No. So now let me give you a hint or a clue like how this algorithm works. Initially we assume some value. Okay, let us say k. So k initially will be 0. So when we get the last digit, and we are going to use an expression which is k will be equal to, so k will be equal to, initially it's 0, now k is equal to k times the remainder, the last digit, which is the remainder. I'm going to multiply it with the last digit. So what will happen if I do this? Okay, so k is initially 0. Yes, but how can we define that? And also we have another observation that we are dividing this with 10 always, because we wanted to get rid of the last digit that we have already extracted. So we don't want that now. So what are we gonna do with the k? So with the k, I want to multiply the value k with what I did here. I'm going to reverse this process. I'm going to say I will multiply k with 10, and since I have removed this, I'm going to add that reminder and see what this expression is giving me. Okay, this expression is saying whatever you have initially, so you have initially k is 0, right? So let us say this is the base. So 0 into 10 is always 0, and we're adding the remainder, which is 3. Okay, what happens when I put this here? Okay, let me put this here. Okay, if this is my algorithm, let me see what's happening with it. Okay, I have 1 2 3 with me. I have 1 2 and 3. So what's my last digit? It's 3. So I have 3 here. So my last digit is 3. And what will be my k? So my k is initially 0. So my k will be 0. Now it's being multiplied with 10. It is still 0, and I'm adding my remainder, which is 3. So now I have k is 3, and I'm dividing mine. So now it's only 12. Okay, now what am I doing? I'm again extracting the last digit. So my last digit now is 2. Now what will be my value of k? So my k will be 3 multiplied with 10, which is 30, and I'm adding my remainder, which is 2. Okay, let's say this is not remainder, this is last digit according to our algorithm. So I will be adding the last digit, which is 2. So now our value is 32. So we have 32 here, and we're again noting the last digit. Now we have 1, and the remainder is again 1. What am I doing? I'm saying 32 into 10, which is 320, plus 1. I'm adding 1, so I got 322. So 321, right? So I have 321, and my n will now be 0. So this condition fails. We exit from the loop, and we're going to print k, because k is holding what we needed, right? So this algorithm is going to reverse that. So let us see if this really works. Okay, instead of, okay, let's take number n is equals to int of input of enter a number. Okay, after I entered a number. Okay, so what have we done first? So we are initializing some k. Initially it's 0, and while n is greater than 0, I'm going to repeat some steps. I'm going to guess the last digit. So how can I get my last digit? N mod 10 will give me my last digit. Now what is my operation? I'm doing k is equals to k star 10 plus my last digit. See, I think you might have some confusion why. So I have done k is k into 10. See here, k is actually the base, and this is actually the power. I think while we refer to, okay, when we refer to a base, so if these are the place values, then this is nothing but 10 to the power 0, and this is nothing but 10 to the power 1. This is nothing but 10 to the power 2, and if it's base 2, it's just 2 to the power 0, it's 2 to the power 1, it's 2 square, and so on. So this is how a number system works. So that's the reason that we have gone with this. So with this value, and now we have our k value computed. Now let's update the value of n. So n will be equals to n. See, in the Python language, this operator will return a floating point number, but we are actually looking for an integer value. So this is the actual operator. N is n divided by 10, and that's it. We can just print it out. So now let's print the value k. Okay, let's run and let's enter the number. Let's give 1 to 3. What is our k? K is 31. So it's working fine. Let's give another number. 1 2 3 4. Yes, we're getting 4 3 2 1, so it's working fine. And what will happen if we give something like a 10? Is it gonna give 1? Yes. So if you have any trailing zeros, it's gonna ignore that. If you have 1000, it doesn't matter, it will still be 1 because all the zeros are going to be ignored. Okay, so since we have already discussed this, I would like to discuss an extension problem of this, which is to say if a given number is a palindrome or not. So I think it's just an extension of this program. So here you just have to compare, and you have to store. Let us say you are storing. Okay, so this is your n, right? Let us say you have m is equals to your n. So you're storing the original value, and your k is your reversed value. If your reversed value is exactly equals to your original, then we can say this number is a palindrome. And it also works with strings as well in the same way. So if we can write this condition, we can just say if a given number is a palindrome or not, right? So let us say original. So the original is n, and let us call this case reverse. Right. Now I'm going to say print. Okay, result is equals to palindrome if reverse is same as original, else I have to return not a palindrome, right? And now we have to just print the result. Okay, let's run this and let's give a number 1 2 3 4. It's not a palindrome because the reverse of it is 4 3 2 1, which is not equal to the original number. Okay, now let's give 1 2 3 2 1. So this is a palindrome because see, it starts with 1, it ends with 1, and then 2, we have 2, and we have 3. So this has to be a palindrome, and yes it is. And let's check for some unique cases like all ones. Is it a palindrome? Yes, it's a palindrome because it's 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 always the same digits. So okay, we can also try with other things like 1 2 2 3 3 2 2 1. Interesting. It is still a palindrome. So this is the program how we can find if a number is a palindrome or not. And yeah, so that's it. I think that's all that we have regarding so these are all the questions that we have on numbers. Mostly they will ask us to reverse the number and find the summation of all the numbers. We can just initialize another variable like sum is equals to initially equals to 0, and I can use sum plus the last digit, and I'm also going to print the sum. So we have it is a palindrome, and the sum is 1 2 3 and 6 and 9. So this program is actually covering all of the cases that we need. So yeah, that's it guys. So I'll meet with another video. Until then, bye.